Hello, welcome to explanation on the fourth proof. This is lesson 8. This is the fourth proof in the assigned proofs. This one is I would give it a 12 or a 13 ranking out of 10 in terms of difficulty. So I'm going to show you the trick to this one. So we have triangle ABC. So ABC, it's isosceles. So those two sides are going to be equal with base BC. Use vectors to prove that the median from vertex A is perpendicular to its base. So are required to prove let's give it a D here, so the vector AD is perpendicular to BC. So when you want to do, if we're doing a Euclidean proof, this is all right leaving it in that form, but we're talking about dot product and cross products. We need to write it, this required to prove part, as a dot product statement. All right. So when you're proving the two vectors are perpendicular, a better statement for us in the vectors course would be to say the median AD, if I did the dot product with BC, the result would be 0. So there's our required to prove statement. We need to write it as a dot product. So this is why this one's so difficult, because you have to come up with your own required to prove statement before you can actually start this question. Now, I'd like to say from that point on, it's straightforward and simple, but for some people, well, for a lot of people it's not, because there is a lot of extra steps in here that you don't realize. So we'll go through this step by step. So that's the first hurdle to get over. Next is proving left side and right side. So again, we start with the more complicated side. So obviously right side is not where we're going to start. So we're going to work on that left side. So vector AD, I want to write it in terms of the given vectors. So that means I want to write it in terms of AB and AC. So that being said, I'm going to hold on for a sec. Let's go to the vector BC. Maybe that'll make a little bit more sense first. How can I write the vector BC in terms of A, B, and C? Well, I'll leave some space for vector AD. So dot vector BC. So starting at B, I'm going to go this direction. So I'm going to go negative AB. Then I'm going to go this direction to get to C, so it's the vector AC. So negative AB plus AC, that will replace the BC vector. Now, AD, much trickier. If I go down AB, I'm going to not be able to get to that D vector, so I'm only going to go part way. So if I go halfway here, then I slide the AC vector over here. I don't want the whole vector, I just want half of it. So what happens, we can slide these vectors, okay, because vectors can be moved as long as they keep their orientation and magnitude. But what we find is we can do this two ways. So I'm going to make this a little bit messier for a second here. And where's my highlighter pen? Let's go with the highlighter. So really, if I was to add AB and AC, what I would end up with is 2AD. Okay, we can look at it that way, or you can go half of AB plus half of BC is equal to that. So what we end up with is AD is equal to 1/2 of AB plus BC. And there's your very tricky, complicated part, is to see that external vector addition. Now we can just go ahead and use our dot product property. So using distributive law, we distribute the vector AB in. So AB dot itself would be the negative of magnitude of AB squared plus vector AB dot AC. And then we do our distribution for BC. So we end up with plus negative AB dot dot BC, and then finally plus BC dot AC. All right, so now we got to do a little bit of cleanup here. So the first one's already a single term, so I'm going to leave it as is, AB squared. Now, I have AB dot AC, and I realized, and hopefully you caught it too, back here for AD, I don't know why I wrote BC. It should have been AC. My mistake, right? Because this vector that I slid right here is AC slid. So I've probably caused a little bit of confusion. So that should have been AC, which makes that AC there. Sorry about that. Now we see I have an AB.AC, I have an AB.AC, but now it's negative. So these terms will cancel out. And at the end, I need, this should be an AC, which would have been plus the magnitude of AC squared. So I've kind of made things a little bit messier. I apologize for that. When I slid AC, I wrote down BC, it should have been AC. Now, what do we know about the magnitude of AB and the magnitude of AC? Since it's an isosceles triangle, they are equal. We're only looking at magnitudes here, so we have a negative and a positive. So then these terms then will cancel each other out. So we have half of 0, which is 0. So therefore, left side equals right side. So hopefully, I apologize, I made that a little bit more confusing than it needed to be. That should have been AC throughout. You can see you did a question, there's a question like that on one of the quizzes where you have to use distributive law, and that's where it comes into play, is in a situation when you're doing a proof like that. If you have any other questions or any clarification, let me know and I'll see what I can do.